Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today we're taking a deep dive into a trending project on GitHub, Daytona, a secure and elastic infrastructure for running AI-generated code. As AI coding assistants become mainstream, safely executing the code they produce is a real challenge. Daytona tackles this head-on with isolated, scalable environments designed specifically for AI workloads. It gained nearly 900 stars today alone, signaling that developers everywhere are wrestling with this exact problem. What if the most dangerous line of code in your application was the one you didn't write yourself? As AI code generation gets embedded into daily development workflows, a quiet but critical problem has been building beneath the surface. Where exactly does that AI-generated code actually run? Not in testing, not in production, but in that split second between generation and deployment. Daytona, a project from daytonaio, has crossed 57,000 stars on GitHub precisely because it answers that question in a way nobody else has quite managed. Daytona is a secure, elastic infrastructure layer designed specifically for executing AI-generated code. Think of it as a sandbox as a service platform, built not for human developers browsing in a browser IDE, but for AI agents and automated pipelines that need to run untrusted code programmatically, at scale, and in milliseconds. The project comes from daytonaio, a team with deep roots in cloud development environments that has clearly pivoted hard toward the AI agent market. The numbers reflect genuine developer interest. 57,658 total stars, 872 added in a single day, and 5,035 forks. That kind of sustained traction signals this is solving a real, felt pain, not just attracting curious onlookers. Here is the core tension Daytona addresses. The moment you let an AI generate and execute code inside your application, you have introduced an actor whose behavior you cannot fully predict. Traditional approaches to this problem are unsatisfying. Running AI code directly on a server risks the entire host environment. Spinning up a full Docker container on demand is too slow for real-time use cases. Serverless functions, commonly called FaaS platforms, are stateless by design and lack the depth of environment control that a coding agent actually needs. What developers building AI agents discovered is that they needed something that behaves less like a long-running IDE and more like an instantaneous programmable execution cell, something that can be created, used, and discarded in the same breath as an API call. The previous state-of-the-art was patching together Docker containers with custom orchestration scripts, accepting either high latency or high security risk. Daytona argues that neither trade-off is acceptable at scale. The headline number is sub 90 millisecond sandbox creation. To appreciate why that matters, consider what normally happens when you launch a Docker container. The runtime must pull or locate an image, set up namespaces, mount file systems, and initialize the process tree. That process routinely takes seconds. Daytona almost certainly achieves its speed through container pooling and pre-warming, a technique where a fleet of generic containers is kept in a ready state. When a sandbox request arrives, the system claims one from the pool and customizes it rather than cold starting from scratch. This is not a novel concept in isolation, but applying it specifically to the AI code execution use case and offering it through a clean API is the real product insight here. The more forward-looking technical claim is file system and memory state forking, listed as coming soon. This points toward technology like CREU, checkpoint, restore in user space, from Linux mechanism that can freeze an entire running container, capture its memory pages and file system state as a snapshot, then clone that snapshot into multiple independent running instances nearly instantly. For an AI agent working through a complex problem, that is transformative. The agent could branch its execution environment at a decision point and explore multiple solution paths in parallel without rerunning expensive setup steps. Beyond execution, the API surface is deliberately rich. Daytona exposes file system operations, Git operations, and LSP, the language server protocol, the same protocol editors like VS Code use to understand code structure, offer completions, and report errors. Giving an AI agent programmatic access to LSP means it can reason about code semantically, not just treat it as a string. The underlying runtime relies on OCI and Docker-compatible images, so any existing container image works as a base environment. Security isolation follows standard container boundaries, with each sandbox operating in its own process, file system, and network namespace. The primary target is developers building AI coding agents, systems that generate code and need to verify it works before presenting results to users. An agent that writes a Python function can spin up a Daytona sandbox, execute it against test inputs, observe the output, and iterate, all within a single user-facing request. The developer never has to worry about that function deleting files or making unexpected network calls on the production server. A second clear use case is AI-powered developer tooling, a code generation feature in an editor or web app that wants to offer live previews of generated code can offload the execution layer entirely to Daytona. The product team focuses on generation quality rather than sandboxing infrastructure. Online coding platforms are a natural fit as well, providing isolated execution for arbitrary user-submitted or AI-generated code is exactly the isolation model that education and competition platforms need. Getting started requires an account on the Daytona platform, an API key, and installing the SDK via pip or npm. The Python SDK reduces sandbox creation to roughly 5 lines of code. Developer reception has been largely enthusiastic. Users report dramatic reductions in environment setup time, with some citing drops from hours to minutes for onboarding new contributors. The open-source nature under the AGPL license and multi-language SDK coverage are frequently cited as positives. The traction on Product Hunt, where it topped daily rankings, suggests the pitch is landing clearly with a broad technical audience. The concerns raised are worth taking seriously. Some developers flag the weaker isolation guarantees of container-based sandboxing compared to full micro-VM approaches like Firecracker, which uses actual hardware virtualization boundaries rather than Linux namespaces. For applications running genuinely adversarial code, that distinction is not academic. There are also early-stage concerns about vendor lock-in at the API layer and the standard caution around curl-piped installation scripts. The community broadly sees promise, but is watching the security model carefully. Daytona is staking out territory between two existing categories: cloud development environments designed for humans and serverless compute designed for functions. Neither was built with AI agent workflows in mind, and that gap is real. But the competitive pressure here will intensify quickly. Cloud providers are well positioned to offer similar primitives, and projects like E2B are pursuing the same market with different architectural bets. The AGPL license is a deliberate choice to prevent cloud providers from offering Daytona as a managed service without contributing back. But that friction also affects enterprise adoption. The deeper question is whether the container isolation model will prove sufficient as the stakes of AI agent execution rise. As AI agents gain more capability and operate on more sensitive systems, the pressure to upgrade to stronger isolation primitives will increase. Whether Daytona evolves its security model fast enough alongside the AI capabilities it serves will ultimately determine its longevity. Daytona is solving an infrastructure problem that most AI application developers are currently solving badly or ignoring entirely. The combination of fast sandbox creation, rich programmatic control, and a clean multi-language SDK addresses a genuine gap in the current tooling landscape. Whether it becomes foundational infrastructure or gets absorbed into a larger platform, the problem it identifies, safe, scalable execution of AI-generated code, is only going to grow in importance.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.